This conference will now be recorded.
Hi there. Good morning, good afternoon, or good evening. So today's topic is process management or managing processes. Now, this topic is really an important topic in which we are going to see many concepts to manage a process, boost a process, and boost the performances of our system. So basically, when we say process is nothing but any activity that goes on in the system. So anything, or in fact everything what we do in the system is called as a process. Even moving a mouse cursor from one location to other location is nothing but giving rise to a process, right? And some processes are also important services, which is also called as daemons. Now, guys, if you keep unwanted processes running in the system, it may unnecessarily take away resources and degrade the performance of your system. So, as a Linux admin, it is our responsibility that we should monitor them and we should make sure that no unwanted processes are running in the system. If there are any such processes which are running, we should immediately take care of it. Okay, so every process is identified with an ID which is called as process ID. Now there are generally three types of processes: interactive process, system process, and automatic process. Interactive processes are those with which you can directly communicate. For example, VI editor. When you open a file in VI editor, it obeys our instructions. When I say YY, it copy the line. When I say P, it paste it. Don't you think I'm directly interacting with these processes? Cat command, VI command, and other commands with which we can interact are nothing but your interactive commands. Then we have system or daemon, system processes or daemons. These are nothing but the services that runs in the system, like HTTPD, VSFTPD, and other important services of your system, which we cannot directly handle, but at least we have a control when it should start and when it should stop, or shall it be running all the time or not. Then the last type of process is automatic process. Okay, let me just look into. Now the audio is fine. Am I audible to everyone properly now, guys? Okay, I don't know what happens to audio. So the last type of process, what I was talking about is automatic process. Automatic processes are nothing but those processes which can start on their own. The best example is cron job. You will simply set date, time, event. So on the given date time, automatically this event will take place. Such processes are called as automatic process. Now there is one more category of process which is called as parent and child process. See, every process that you have in the system is having a parent process. The parent process to all process is systemd. When the system is booting, the first process to start is systemd, and eventually systemd becomes mother process to all the processes in the system. But apart from this, sometimes it happens that when you run a process, it may give rise to one more process in the background. So first process in this condition is called as parent process, and the other process that is started by this first fellow is called as child process. For example, you have run a command ls-l, and then you have used the pipe grep. So you see ls-l is a parent process to grep because grep has been started by ls-l. Now, like that, this is very an ordinary explanation I'm talking about this, but mostly what happens is when you start an application, it starts the services, it takes care of few other processes also, like that it goes. So the story is when you kill the parent process, automatically all the childs associated to it should also be killed. But in some scenario, rarest it happens that you kill parent process, but still child process will be running, right? So what do we call such process? See, normally when a parent process is killed, all the childs associated to it must also be killed. But in few cases, it happens that when parent process is killed, child somehow skips, right? And it would be still running. So such process whose parent process is killed but childs are still running, we call such processes as zombie process. Guys, zombie process are not good for the system because they would be running unnecessarily and eating away the resources of your system. So as a system admin, we are responsible for this. We should find zombies and we should kill them. So we'll learn how we can search this zombie process and how we can get rid of it. Okay, now let's log in into the system and let us see how we can manage these processes, how to check process IDs and all other things. So first of all, I want to check on my current terminal, right? Who am I? So you see we are root on PTS 0. I want to check how many processes are running associated to my terminal. So you can run ps command. So it says on PTS 0, there are two processes running. One is bash, other is ps command. Bash is the shell we are using, and on that shell we are running ps command. You see, it is associated with an ID and how much time it was actually used. So rarely for 1 second or less than 1 second I have used it and then it stopped working, right? But guys, I want to see all the processes that are associated to this terminal, even if it is running in the background in hidden mode. So to see all processes on your terminal, you can say ps-a. So guys, it would tell you that on this terminal, some are hidden, some are openly working. So these are all processes that are associated with your terminal, right? Maybe which are not directly attached to your terminal, but it is associated with your terminal, right? That's how we can find all the processes which are associated with our terminal. Now moving ahead, I would also like to see what other users are doing. See, as a root, you always have power to see other people's work also. So I'm logged in as my user, and as my user, I would be creating some file. Now, as a root, I want to check what my user is doing. So you can say ps hyphen u, capital U or small u, both are fine, followed by username. So it would tell you that my user is using all these processes, right? Where two processes are connected to terminal PTS1 like bash and SSH. There are few other processes which it is using, but it is not attached to any terminal. Question mark means these are important background processes which would always be running and they are not associated to any terminal. See, the reason is if you kill the terminal or leave the terminal, all the processes running on that terminal will be killed. Now, if SSH is killed, nobody will be allowed to log in into the system then, right? So over here, it is showing you those processes also which are not associated to any terminal. Same way, if there is a group which is associated to a process, you can say ps-g followed by group name. So all the processes associated with that group will also be listed out. Okay, now what I want to do is I would like to see all the processes regardless of terminal, regardless of user, and whether they are running or standby. I want to see each and every process that is associated to my system. So you can say ps-ef, go for more. When you say ps-ef, it tells you what is the username this process belongs to, what is its process ID, and what is its parent's process ID. If there is any parent, it would show you who's the parent. Then start time, is it attached to any terminal? Active time, how much time it actively used the resources, just 5 seconds like that. And the process name. Same way, you can also check the status of a process. That means, is it running or standby sleeping, or is it a zombie process? So to check the status, you can go with ps-elf. In long form, you can see more details. So over here, it tells you the status. Now in status, if you see S, that means it is sleeping. If you see R, that means it is running. If you see I, these are kernel threads or CPU threads. So we don't have to worry about that kernel internal threads on all. It's only for display purpose. So our concentration should be S for sleeping, R for running, and Z for zombie. So if you find any Z or Z, that means it's a zombie process and we should take care of that. Now ps-elf will also give one extra thing called nice value. Now what is that nice value? What does this -20 or other things are? We will discuss in a short while. Now guys, I also want to see the consumption of the process, that each process is eating away how much resources. So you can say ps-aux. When you say ps-aux, it shows you that each process is taking away how much CPU and how much memory. So percentage of CPU and percentage of memory utilized will be displayed by ps-aux command. Now moving forward, let us learn that if a process misbehave, how you can kill that process. See guys, killing a process or terminating a process again is an admin task. You must be logged in as root to do this activity. See, basically there is a concept called signals. And you know what signals? Signals are the way to send messages to processes. Like the way when we go out on road, we see traffic signals. Now those traffic signals have some messages: red to stop, green to go, yellow to be prepared, right? Same way, we have signals in the system that we can send to any process. Now, some signals are so deadly that if that signals are sent, the process will be killed out. To find all the signals, you can run the command kill-l. So when I run kill-l, it displays all the process signals that you can send. Now there are many important signals inside it is there, but one signal is widely used, that is signal number 9, sig kill. So if you send any process signal kill, then it is going to kill a process. Same way you have signal number 15, that is terminate. But signal terminate is very polite signal. It would wait for the process to end and then it will stop it. It won't immediately force it to kill. But signal number 9 is the deadliest signal, that it is going to definitely kill a process forcefully, right? So if a process is not obeying you and you want to kill it, then how to do that? Let me show you. You can say ps-u any process. For example, I have this VI editor and the process is 2244 process ID. To kill that process, we'll go with a command kill hyphen signal number 1 to 64, whichever signal you want you can send. To kill a process, and widely used only one signal is there, signal number 9. Towards which process? 2244. So when I say kill that process, see my user is actually working on that file, right? And when I hit enter, you observe that my user has received a signal and the process got killed. So it was just an example. I showed you that how a process will be killed. Any process in the system, if it is misbehaving, we should kill that process. Especially zombie processes, if you find, you must kill it because it is going to consume resources of your system unnecessarily. Okay, now let's talk about the next topic, which is priority. See guys, priority is a concept that we deal the most in our day-to-day activity, right? Priority is importance, preferences. Now, in your system, you might have many processes running. Now, not all processes would be important for you. So, what you wanted to do is you wanted to set a priority that your most important process must get high resources all the time, and the other least important must get least priority. So according to priority, the CPU and memory will be given to a process. If a process is really important for me, I'm going to set high priority. If a process is not that much important for me, I'm going to set low priority. Now, priority depends on a value called nice value. Now, nice value ranges between -20 to +20, right? Now, it is inversely proportional concept, guys. Like lower the nice value, higher the priority, and higher the nice value, lower the priority. So if number is in minus, that means you are giving high priority. If number is in plus, that means you are giving low priority. Lower the number, more priority. Higher the number, low priority, right? So it affects all the resources, especially your CPU resources, and prevents your system from slow down. So there are two scenarios in which we can set this nice value. First scenario, when you are starting a process. Now again, this is an admin task. In order to set the nice value, you must be logged in as root user, or at least you should have sudo power. So I'll say nice hyphen n, whatever value you want to set. I'm setting a low priority +5, and the process you want to start. Now it can be anything, cat command or npm commands, or maybe you are running a script or running Ansible commands, whatever it might be. So I'll say nice hyphen n 5. So 5 is nothing but the nice value, low nice value. Then the process cat greater than xyz, whatever. So now if I go back to another terminal and if I say ps-elf To find the nice value, you must use ELF, and here we can grep for cat command. So when we go for cat command, you see here is our cat command, and nice value is 5. See, the default nice value is 0. When you start a process always start at 0, neither low nor high. But we can re-nice it or we can modify it. So as you see, I have started this process with a priority 5. Now let us say that I found out that the process is running little slow. So I want to boost the performance of a process. How we can boost the performance? By reducing the nice value or making the value in minus. Now this we will do a lot to tune up the performance. Any your important application, if it is not working perfectly, to boost the performance, we will increase the nice value. How we can change a process nice value now when it is already running? We will go with a command renice. So you need to say renice whatever value you want. I want -5. For which process? 2407. So you see it says for this process the old priority was 5, but now the priority has been changed to -5. You can again run ps-elf and confirm that now you are having a high priority. So this is the way how we can increase the performance of any process. As of now, we may not see any difference, but on production, when we are dealing with important uh, production applications, in that scenario, it is going to be very vital to set up the nice value, and we can make sure that our process is getting good resources and performances reflected. Now, moving forward, it is also our responsibility to monitor some important processes in our system, right? Like for diagnosing what is the problem in our system, to check the health of our system, we go with these important process monitoring. Like guys, there are four critical pillars of your system: CPU, memory, IO network. If any pillar fails, our system will be failed. So as a system admin, we should monitor the usage, or at least we should know how to check the details related to them. So guys, just now we have seen PS command and various options with PS command. Now the command what I'm trying to show you is SAR, System Activity Report. Guys, SAR is one of the wonderful command to collect reports, generate reports related to CPU utilization. But unfortunately, I don't really understand this concept that why SAR is not pre-installed. Till Red Hat 7, SAR used to be a vital command that comes pre-installed in our Linux. And most of the Linuxes we use SAR command to see CPU utilization. But now in Red Hat 8, when you run SAR command, it says it is not installed. But thanks to DNF, see guys, this is also a part of DNF, a difference between YUM and DNF. See, when you configure the DNF command and when you run SAR, it would tell you that command not found. But in a short while, it will come back and says that if you installed systat, you will get SAR command. So how beautiful it is. If any command is not working, DNF would come to rescue and it would says that okay, the command is not there, but that command might work if you install this package. Now would you allow me to install it? You need to say yes or no. When I say yes, it will continue with DNF to install the package. One more time, I'll say yes. See, it says what is that package? Collection of performance monitoring tools for Linux. So I'll say yes, go ahead. So this is the beauty of DNF server, what we have configured in previous class. So you see the package is installed. but we need to start the service of sysstat. As of now, if you check it out, systemctl status sysstat, or mm, sorry, should be working with this stat. I'm sorry, I did a spelling mistake. It is sys, sys, and stat. I use single s, that's the reason. So you see, it says it is enabled. Enable means from next reboot onward, it is going to start collecting the CPU resources. And whenever you reboot from that time only, it will start collecting the report. So one thing what you can do is you can reboot your machine, and since your system is rebooted, it will start collecting the report. Or if you want to start using from now onwards, then you can start simply the process. So you can say systemctl start sysstat. Now go back again. You will find out that the service is now active and it is also enabled, so I don't have to enable it again, right? So what I'll do now, I'll say SAR. So when I run this command, first of all, it will tell me which OS I'm working with, what is the kernel version, what is the host name, what is the date and architecture, and how many CPUs are connected to my system. And when the system started, it is giving the date. So as of now, it is taking the start time from the time when we have started the services, right? So it says at that time system restarted. But anyway, that is not a proper restart time as of now in this condition. In this condition, we have started the service forcefully, so it is taking that the service started time as the system restart time. Anyway, now let us say that uh, if this SAR is properly running, then you will find the information like this. It would start telling you that when the system started. And since system start, every 10 minutes, what was the CPU performance? 730, like you see, 740, 750, like that, it is going to collect the report, right? And it says the CPU has been used by all type of processes, user process, nice process, system process, how much time it is waiting for any activity to happen, is there any zombie activity of stealing your processes, and how much time the CPU is idle. Now guys, this is history what it is showing. If you want to see the live performance and live effect, then you can go with SAR 1, where 1 is nothing but 1 second in time interval. See, I want it to continuously repeat SAR output every 1 second. So you can say SAR 1. So every 1 second you'll find, see, so every 1 second the output is being generated. So like that we can see live effect of your CPU utilization. To stop it, I have to press Control C, right? Now let us say that after some counts, I want it to automatically stop running SAR command. So you can set the count value, suppose 4 times. So every 1 seconds, I want to repeat this task for just 4 times. So when I say SAR1 followed by 4, you see it will repeat for 4 times, and after 4 times it is going to automatically stop, and it presents you the average value of that 4 time, right? So this is the way how we can use SAR to collect informations. Now, guys, I would recommend to please go through with man pages because these commands are ocean. Believe me, lots of things you can do. You see, with SAR, there are many things you can do. You can store the output in a file by using -f. You can even set start time and end time, when to start collecting and when to end that collection of report. So when you go with these things, it is going to collect a report from so and so time to so and so time automatically, and the output you can collect in a file so that later on you can view. So whenever there is an issue or something, you can diagnose the issues like that. And man pages definitely has example. So if you go for that, it is going to explain you. And each and every flag also, it is going to explain you what is there inside it, what is the meaning of that output, all that thing you may get from this man pages. So just five minutes or 10 minutes reading this literature would be a very helpful affair for us. Lots of things are there. I'm just going through the man pages and it's going on and going on. Okay. All right. Now, if you want to view details about your CPU, then you can go for cat proc CPU info. This will describe your CPU. Or guys, you can also go with a wonderful command lscpu. lscpu actually collect the information from proc CPU file only, but it presents in a proper understandable way. So what is the architecture? 32-bit software, 64-bit software, both are supported. Two CPUs are there. CPU IDs are 0 and 1. How many threads are there per socket and how many cores are there per socket? See guys, socket is nothing but the place where your processor will be connected on motherboard. Now that socket will be having cores. How many cores you have, that much high performance your system would be. Each core will be behaving as an individual processor, so that much power it might have. And cores are divided into threads that carry your processes. So here it is telling you one socket is there, two cores are there inside it, and each core is having one thread inside it, like that, right? So if you enable multi-threading, each core will give you many threads. So many processes can be executed in a single CPU cycle. And guys, what is the model name? Right, Intel Core i7, and this is the clock speed, something like that, 2.6 gigahertz or 2.8 gigahertz. It is showing you. If you are working with a virtualization, what type of virtualization you are working with? Is it half or full virtualization? This is really wrong. We are working on para virtualization, but still it is showing you full. That's a mistake because we are not going with full virtualization. Full virtualization means ESXi, Citrix, Zen, etc. Okay, so this is the way you can check the details about your CPU, right? Now moving forward, the next thing what we have to monitor is memory. So with memory we can use some commands like free command, swap on command. We have learned that in swap class. Now the command we are going to work is with vmstat. So when I say vmstat, it is going to show you many information under one command, like how many processes are running, what is the memory status, how much swap space is used, how much free memory is available, how much memory is in buffer or cache, and especially in swap, how much swap in and swap out activities are going on. If you have hard disk, how much block input and block output is going on, reading and writing, how many system processes are running, and what is the detail about your CPU usage. Same SAR, user, system, idle, wait, steal, right? These are all same like your SAR output what we have seen. Now, when I say vmstat to continuously monitor the output, you can say vmstat1. So it would show you the live status of swap in, swap out, and memory usage that might be going on, right? If you want to stop this process after 4 counts, you have to say for every 1 second, just stop it after 4 counts. So every 1 second the output will be generated, but automatically it will stop after 4 counts. 1 is time interval and 4 is number of count. Again, vmstat can do many important things. If you go with vmstat help, it shows you many options are there. It is going to display many things. You can go with any option and it would try to show you. Folks are nothing but total number of processes that have been executed so far, right? Same way you can go for vmstat -w, right? Little wider output you will get, right? Same way you can go with vmstat-d or vmstat -D. It is going to describe the information about the disk, right? The most important option what I like is vmstat-s. This is going to describe your entire memory. What is total memory? How much memory is used in KB? How much is active memory? And how much is inactive memory? How much memory is free? What is the memory buffered? Right swap detail. Most importantly, non-nice processes, nice processes which are consuming your system, right? Many important details it is giving you. Same information you can gather from proc mem info. Last time we went with CPU info. This time we'll go with mem info. So you see, it is going to show you all the memory details. Same thing what vmstat-s has described. Similar information you are getting over here. Okay, all right. Now the next thing what we are going to monitor is I/O. Guys, when I say I/O, basically I/O stands for input output. In this case, we are talking about the disks which can read and write, which can take input and give output, right? So the disk can be your hard disk, the partitions inside it, or LVMs, or pen drive, tape drive, CD drive, whatever drive that can read and write data will come under this IO option. To monitor readable, writable disks and all, we have already seen fdisk command, parted command, df command, du command. Now the command we are going to concentrate is iostat. When I say iostat, it is going to produce a good amount of data related to your system, same SAR output, same SAR. Then it is talking about how many devices are connected. SCD is nothing but your CD, DVD, ROM. SDA is our hard disk. TPS stands for transfer per second. So per second on an average, how many IOPS are going on? Input output per seconds. That means per second how many input output ticks are going, right? So it says that CD is hardly 0.02, whereas SDA is 5.87%. Now, how much reading per second is going on? How much writing per second is going on? Total reading so far and total writing so far in KB. Now, if you want to continuously monitor it, then you can say iostat 1 time interval. Every 1 second, it is going to repeat the output until unless you press Ctrl C. If you want to stop it after a certain amount of time, then you can say iostat 1 followed by 3. After 3 counts, automatically it is going to stop. Then, I'm sorry. Let's move forward And let us say that I'm not interested to see all the disconnected and their detail. Maybe there are 10, 20 disks connected to my system. Now I don't want to see all 10, 20 disk detail. What I want to do is I would like to see a specific disk or partition detail. So you can say iostat -d followed by the disk name. So if you want to view entire disk performance, you can say SDA. Specific partition, you can say SDA1, SDA2, like that, right? Or two partition detail, you can say SDA2, SDA5. So like that it is going to view. Now you can say 1 and 3 or 4, so you can monitor them continuously, right? So this is the way you can go with iostat command. More on iostat you can definitely learn if you spend some time reading man pages. Then guys, we have another commands like lsblk, which we have already seen, to check the details of your hard disk and partitions where they are mounted. To see all USB device or USB port, you can go with lsusb. So as on virtualization, USB port doesn't matter, but on physical machine, maybe it may be a good idea to find USB devices and all. Now moving ahead, I also want to monitor network. Now guys, to monitor network, you can go with a command ifconfig, ethtool, mii-tool, and ping command. All these commands we have seen. To test the connectivity of other machine, we'll go with ping. But the command what we are going to target now is netstat. If you simply run netstat, it might show you ongoing processes that are consuming network and their details with their process IDs, and which machine is connected to our system right now. The machine that is connected to our system is 10.2. Right now the connection is established, and many other processes which are being used by network. But if you want to see uh, only listening ports, then you can go for netstat -ntlp, or in fact you can go for ntulp, network TCP, UDP, listening port. So when I hit enter, it shows me all those ports and services which are right now active. So you see port number 111, it is listening. Listening means right now it is active. 53, it is listening. That means it is active. 9090, it is also listening and active, and other ports whichever might be in use. Okay, all right. Same thing you can find with ss this thing also, right? So ss command will also show you the status that which service is running, what is the port number and all that thing. But I prefer personally netstat more than ss command. Anyway, now netstat can do even more things. With netstat, you can find out the routing table that your system is connected to how many gateways. So you see it describes that our system is being used with a gateway 10.1, right? In fact, you can also check your adapter details. You can say netstat-i. So when I say netstat-i, it is going to show you your adapter details, right? In adapter, how many OK packets, good packets have been transferred, how many packets was having errors, and how many packets dropped, and how many packets jump over. This is the information, how many packets have been sent, and how many packets have been received from outside. That information, same way, is mentioned on the other side. So each adapter details it is giving you. You can continuously monitor it by typing 1 to see how it is performing right now. This is the way how we can go with netstat command to see more details, right? Now moving forward, we have a wonderful command, guys. See, graphically, like in Windows, you have Task Manager, or if you log in into Cockpit also, in Linux Cockpit, it might show you different processes going on with graphs, charts, and all. Similar to it, on command line, we have a wonderful command called top command. See, top command is one of the nicest command to continuously monitor resources of your system. When you run simply top command, it opens one utility that continuously display the usage and top processes of your system, which is consuming high resources, right? So top command start by telling you what is the time in your system and your machine is up for how many minutes, how many users are logged in, and what is the CPU load average, current average, 5 minutes earlier average, and 15 minutes earlier average. So on an average of 5 minutes, 10 minutes, and 15 minutes, how was the load? So you see this time 5 minutes earlier, 15 minutes earlier, there was no load. So our CPU is running smooth and fine. Total, how many tasks are ongoing? 175. Out of all, only one is running. 172 or 174 are sleeping. Zero are stopped processes and zero are zombie process. That is good sign. Then CPU usage, memory usage, swap usage, it is displaying same like SAR, right? Then at the bottom, it is telling you what is the process ID related to this process, who's the owner of the process, what is the nice value of that process, what is the status, R for running, I for kernel internal threads, CPU threads, ignore it, and CPU usage percentage, memory usage percentage, and cumulative time. Cumulative time is nothing but the process was active for how many minutes or hour before sleeping. So actively, a process has run for how many seconds or minutes or hours, followed by the command that is used to execute this process. Now guys, you can arrange the output of this command as per your requirement. You can just type H for help. When I say H, it is going to display the commands that we can use with top command. So for your reference guys, I have already kept some important options over here. Like you can go for M to arrange the output with respect to memory consumption. Suppose I want to see memory intensive programs. That means all the processes that are consuming high memory, I want to display on the top list. Then P to arrange the output with respect to processor used or CPU used, to arrange the output with respect to top processor consuming processes. Then T to arrange the output with respect to time, how much time the process has been used the resources. Z to display the output in colors. L to locate or find a process. R to renize a process, and K to kill a process. Q to quit, right? So I'll again press escape. First of all, to see the output in colors, I'll use Z for Z, I mean for colors. So when you say Z, it presents the output in color. If you're capturing the screen, it would be nice if you do it in colorful. Then if you want to arrange the output with respect to memory consumed, I'll type capital M. I don't have to hit enter, just type capital M. automatically the output will arrange with respect to memory consumed. So top memory consuming process is someone called gnome shell, which is actively using the resources for 15 minutes 23 seconds. Then the next is 8 minutes 47 seconds, right, like that, which is consuming 4.5% of your CPU. 3.4, 2.7, 2.2, in descending order it is going. Same way, if you want to arrange the output with respect to processor consumption, you can type capital P. So highest consumption of processor is 0.4% or now 2.3%, then 0.3, then all the others, right? Fine. Now moving forward, I would like to arrange the output with respect to cumulative time. So you can use capital T. The longest active process is 18 minutes 14 seconds, and this is the process name RNGD. Now, if you want to search a process, then you can go with capital L and type the name of process you are looking for. Maybe I'm looking for SSH. So you see SSH has been searched. Or I'm looking for cronD. So you see cronD comes first. So like that you can search any process and get the details related to it. Now let us say that this process has 0 nice value. Maybe I want to give it -5 nice value now. How can I renice a process? You have to type R. When I type R, it is going to renice a process. What is the process ID you want to renice? I want to renice 1218 process. That's the default value also it is taking. And what is the nice value you want to give? Maybe -5. So you see, I'm just resetting the nice value within top command only. Now suppose same command is running unnecessarily. Maybe it is a zombie process or something other process which I want to forcefully stop. To kill a process within a top command, you can use K for kill. Which process you want to kill? 1218. Now observe cronD, which is the signal you want to send. By default, it is taking 15. I'll make it more dangerous, 9. 9 will definitely kill a process. So you see, it went on and kill the cron process. So that's the way how we can make use of this stop command. To come out of this stop command, you can type Q. Again, guys, spending some time using man will be a great affair. And nowadays, guys, what happening is instead of individually logging into every machine and collecting the report, we are going through something called monitoring tools. So one specially Linux machine we will take, and on that we will install some monitoring tools like we have Nagios, or you have Zabbix, you have Solar Wings, or we have BMC Patrol, Big Brother, and many other tools are there, whatever it might be using. And all these tools, whatever you might be using, they will be integrated with clients. So clients would be having their agents installed. So these agents will be continuously sending the report to your centralized monitoring tool. So whenever you want to check the detail from your laptop or desktop, you can just connect to your monitoring server. And that monitoring server will describe all the details related to each and every client that is connected to your monitoring system, right? So different software or different tools are having different output. You can generate beautiful charts, you can generate and graphs, many things you can do. So if I just take you over here and let's see Nagios screens. So you see it would be like this. It might generate different diagrams, and which are running smoothly will be presented in green color. Someone, if it is critical, it will show in yellow color, and if it is out or down, it would display in red color. So with that, you can connect to all the clients, connect their CPU detail, memory detail, network detail, IO detail, all that thing we may collect. And you can set alerts also inside it. If you set alerts, if anything goes wrong, automatically you will be receiving emails and all. So you can just go through Google and try to find out how this monitoring tools work, how to install and configure them, right? So nowadays people are working with that monitoring tools, and there are few virtualizations like ESXi, which comes with built-in virtualization. So if you have an ESXi environment, all the virtual machines running inside it can be monitored by its own monitoring tool. You just need to set some triggers. When you set a triggers inside it, if CPU is low, you'll get an alert. Memory is low, you'll get an alert. Whenever system is shut down, you'll get an alert. So all these things are coming up to find out the details about the health of your system. So that is it, guys, from my side. If you have any questions or queries, you can put your questions now. Okay, it seems there are no questions, so we'll stop the session here, guys. Thank you very much. Let's meet up tomorrow and we'll start our first server. So now we are moving to the last phase of your Linux administration, in which we are going to cover all important servers, right? So for tomorrow's server, FTP server, I would request every one of you to please brush up SE Linux. Tomorrow we are going to learn a very important thing related to SE Linux. So you should know what are booleans, how to check context, how to change them, how to check booleans, changing them, state of SE Linux, because I'm not going to repeat again all that thing. So just have a look on SE Linux chapter and brush up SE Linux. It is useful for tomorrow's class. So on that note, we will stop the session here, guys. Thank you very much. Let's meet up tomorrow.